Welcome to the last topic that we're going to be talking about in the course, and that is correlation coefficients here in week 8. And you'll note that I changed the reading for this week to chapter 11 in the text to read about correlation coefficients. There are three basic types of correlations that we want to get a grasp on. First, there is what we would call a positive correlation. A positive correlation is when there is a relationship between two variables such that high scores on one variable tend to correspond with high scores on the other variable. So, let's suppose, for example, in my research, I was interested in seeing whether or not people who watched a lot of paranormal type television programming, shows about ghosts and flying saucers. Let's suppose I wanted to see whether there was a relationship between that variable of how much paranormal TV programming people watched and their belief in the paranormal. I might measure their paranormal beliefs with a standard measure, and I might ask them how much of that kind of programming they watched. And if there was a positive correlation between those two variables, we would see that across our sample, as the scores on one variable tended to increase, let's say the amount of TV programming that they watched of that type tended to go up, then the paranormal beliefs that they recorded also might tend to be greater. That would be an example of a positive correlation. A second kind of correlation that we might observe is a negative correlation, where there is a relationship between the two variables such that high scores on one variable tend to correspond with low scores on the other variable. So another example from media, let's suppose we measured children's academic performance in elementary school, and we measured the amount of television that they watched during the week. It might be that as we saw the scores on television viewing go up across our sample, academic achievement of those children tended to drop, tended to go down. That would be an example of a negative correlation. And finally, we might have a zero correlation. That is, it could be that the magnitude of a score on one variable has no particular relationship to the magnitude of a score on the other variable. So we might pick two variables and correlate them, and we might find that there is no correlation between those variables, that they're simply unrelated to each other. Now, in terms of the values of correlations, the closer the value of a correlation is to zero, the more we can be confident that the variables are not related to each other. So the statistic that we're talking about here, and we talk about a correlation, is the statistic R, and R takes on a value when we compute it. The closer the value of the correlation is to zero, the more confident we are that the variables are not related to each other. The closer the value of the correlation is to 1.0, and it could be either positive or negative, the more we can be confident that the variables are related to each other. So it doesn't matter if the sign of the correlation is positive or negative. If the magnitude of the correlation approaches 1, or if it's greater than 0, then the greater our confidence is that the variables are actually related to each other. Zero correlations imply no relationship. Correlations of 1.0, either positive or negative, imply perfect relationships. I've also, for this week, assigned reading that you've already done on research methods, and in that chapter that I gave you earlier in the course, there is a discussion of correlation coefficients with diagrams, and I would recommend that you refresh your memory of that. Go back and read that again. I've given you the page numbers in the posted reading. That's in the resource material on research methods. Now, Guilford has suggested ways to interpret the values of correlations, and I also think this is in the reading that I posted. Correlations from 0 to, or correlations that are under 0.20 are generally slight, very low correlations, almost negligible. From 0.2 to 0.4, low correlations, there's definitely a relationship, but it's a rather small relationship. 0.4 to 0.7, moderate or substantial correlations. 0.7 to 0.8, 0.9, high, very large correlations. And 0.9 to 1 are very, very large. We almost never find that when we're associating variables in research with human beings, but sometimes we do. I've been computing correlation coefficients in my research for many years, and it would be very rare in the variables that I've worked with to find correlations in the high or very large range, 0.7 to 0.9. I've had a couple of occasions where I have found associations that high, but not very often. Most of the correlations we find in the social sciences are on the order of 0.3 to 0.7, so somewhere in the low or small range to the moderate range. But that's one way of just getting a general sense of the how we interpret the value of the correlation coefficient. I say here there's graphs of correlations. I'd refer you then to the posted reading that we have in the resource file, where you can see the various graphs of correlation coefficients, what they look like. Correlations that range from very low to very high. Now there are some assumptions of the Pearson correlation statistic. Before we would compute it, we have to make sure we check off on these assumptions. One is that the sample on which the two variables are measured is a random sample from the population. So remember, we talked about probability and non-probability samples. In order to make sure that we're doing this properly, we wouldn't want to compute a correlation on a sample that's a convenience sample or not selected randomly from the population. Secondly, we would want to make sure that the two variables are distributed normally. So you know what a normal distribution looks like, and we'd want to check that before we did a Pearson correlation on our variables. The variables should have approximately a normal distribution, and the variables should be measured at least the interval scale. Now, we haven't talked about interval scales as such and levels of measurement, but I would refer you in the text to pages 204 to 207, and on those pages you should find a discussion of levels of measurement, and it goes over the difference between nominal, ordinal, and interval levels of measurement. Let me just check that to make sure I got the right pages. I think I do. Yes, pages 204 to 207 in the textbook, you'll find a discussion of levels of measurement. Also, another assumption is that the two variables are not related in a curvilinear way. That is, you could imagine that you might have two variables such that as one variable increases, the other variable increases only up to a certain point. And when the one variable gets to that certain point, maybe the other variable starts to decline. And that would be a curvilinear relationship. If you used a Pearson correlation statistic on that kind of data, it would give you very misleading results. And so you want to make sure that the variables are not curvilinearly related. There are other curvilinear techniques for assessing a relationship that go beyond what we're going to get into in the course. Now, the computational formula for the Pearson correlation, we're not going to be paying much attention to that. The computational formula is in your textbook in Chapter 11, and you don't need to worry too much about that. We're not going to be doing computations actually of the Pearson correlation coefficient, but the computational formula is there if you want to see it in Chapter 11. After we compute a correlation coefficient, we want to determine the significance of the Pearson correlation. And what we're talking about there is we're trying to make a conclusion about whether or not the two variables are significantly related or whether their relationship is simply due to chance or not different from what we might expect by chance if we went into a population and drew a random sample and measured any two variables. So for this, we're going to refer in the back of the book to Table E, which is the table of critical values for Pearson correlation coefficients. And what we would do for a given data set is we would locate the critical value, and we would determine whether or not the computed value of our correlation statistic R compares with that critical value. And our decision rule is that if the obtained or computed value of R equals or exceeds the critical value in the table, we reject the null hypothesis that the two variables are unrelated. So the null hypothesis for this test is that there's no relationship between the two variables. And we're going to determine that by taking our computed value of R and looking at the critical value in the table. So if you flip back to page 624 and look at table E, let's suppose for this class, I think we have 24 people in the class right now. For this class, let's suppose we computed the relationship between a person's height and their weight. And if you look at the table, you'll notice that there's a column there called DF, or degrees of freedom. That's a function of the number of people that we have in the class, the number of pairs of scores, and we enter the table at the number of pairs of scores minus 2. So if we have 24 people in the class that we measure height and weight on, we're going to enter the table at 22 degrees of freedom. The number of pairs of scores that we have, 24 minus 2, and we look at the critical value there under alpha equals 0.05 at 22 degrees of freedom, and we see that the critical value is 0.404. So we would compute our correlation between these two variables, and we would compare it to 0.404. If our computed value is equal to 0.404 or it exceeds that value, then we would reject the null hypothesis that the two variables are not related, and we would say that we have a significant relationship between height and weight, which I would expect we would get if we did this correlation. So that's the decision rule. We compare our computed value with the critical value in the table at the appropriate degrees of freedom, which is a function of the number of pairs of scores that we have. So for that example, if we got a correlation of 0.5, we would look at the critical value of 0.404 and we would say, we've exceeded that. We have to reject the null hypothesis that the variables are unrelated. We would conclude that we have a significant relationship between height and weight. If, on the other hand, our computed correlation was, say, 0.38, we would compare it to 0.404 and we would say, well, we didn't make it. It does not equal or exceed the critical value. We have to accept the null hypothesis, and we would conclude that the variables are not related to each other. So that's our decision rule. Now, generally, computer programs have the significance tables built right into them, and they would tell us for a computed correlation coefficient whether or not we have a significant correlation or not. So the decision rule again, if the obtained or computed value of R is less than the critical value, we accept the null hypothesis that the two variables are unrelated. Now, there's also something called the coefficient of determination, and in the posted reading where I talk about correlations, I talk about the coefficient of determination. That's R squared. R squared is the correlation coefficient squared, and that's an indication of the percentage of information that we have in variable X that's also contained in variable Y. And we talk about this as the variance accounted for by one variable in another variable. So it's really a way of getting the overlap between the two variables. Now the chapter, and I'm not really going to talk about this too much. The chapter also gives you another correlation called Spearman's rho that's appropriate for ordinal data. We're not going to pay too much attention to that right now. You can read about it. It's another way of computing a correlation coefficient between variables that are not at the interval level, but instead are at the ordinal level. And I've got some slides here that talk about Spearman's rho, but we're not really going to pay too much attention to that right now. So that's generally all I wanted to say about correlations at this point. Make sure that you watch the video in the resource material file in the Against All Odds series on correlations. There's a good video there that talks about correlation coefficients and gives you some very practical applications of correlations. So you'll want to pay attention to that before you take the quiz this week. Okay, that's it. And that's really all the material that we're going to be going over here in lecture as we come into the last week of the course. I'll probably visit with a video before the course wraps up here at the end of the week. That's it for now.